All right, so here we are with 10.4, perimeter and area in the coordinate plane. So basically we're going to be looking for, again, perimeters and areas based on a shape that has been plotted on a piece of grid paper. So some formulas that we need to recall in order to figure out what's happening here. This is called coordinate geometry, so you need your slope. So in order to find your slope, remember that your slope is your second y value minus your first y value over your second x value minus your first x value. Or potentially, if you can count that nicely, we could also do rise over run as well. Some things to remember with slope is over here. When you have a same slope, that means that you have parallel sides. Very helpful because parallel sides happen in parallelograms, happen in rectangles and squares and all those good things. So definitely want to know if things are parallel by having the same slope. If you have opposite and reciprocal, remember opposite meaning positive or negative and reciprocal meaning flip the fraction. That means that you have something that is trying to think of the word. Okay, opposite reciprocal means that they are going to be perpendicular. Wow, that took too long to remember. Perpendicular, or technically 90 degrees. And so again, very helpful to note because 90 degrees are in your squares and rectangles and some trapezoids, and it's very helpful if you can actually figure out if there's 90 degrees sitting there, because then you will be able to identify the shape and if it is that shape. After that, we also have the distance or the length formula. And so remember that in order to find the distance or the length, you're technically using the Pythagorean theorem. But because a lot of times we're using coordinates, one way to use the Pythagorean theorem then is to say that your distance is the square root of your x's subtracted, but then that quantity squared, added to your y's subtracted, and then that quantity squared. So we've got our distance formula, our slope formula, and the idea of what happens when you have same or opposite reciprocal slopes. All right. So then we're going to go ahead and do 2 examples here on our notes to identify what's happening. So what they want you to do is draw the image, and of course that means plot these points, and then we're also going to classify this. So 4 points means it's probably going to be a 4-sided shape, and so we're going to name it a square or a rectangle or whatever it happens to be. So in part point A here, we need -4, 1 as our first coordinate. After that, we're going to 2, 4, then 4, 0, and then where am I? -2, -3. All right. And so, as you can see, there's probably a rectangle happening here. But as we know in geometry, we cannot just go ahead and say that. We're going to have to prove it. So how do you prove that something is a rectangle? Well, you could say that the opposite sides are the same length, right? And that they meet at 90 degrees. You could say that the opposite sides are parallel as well. That would be fine. So kind of a lot of ways. And of course, we went over all of those in chapter 7. So you can reference back to that if you would like. But in this case, we're just going to classify it by a rectangle having opposite sides being the same length. So I'm going to show that AD, the length, is equal to BC. And that AB and DC are equal. If I show that, then I now have opposite sides that are the same length, which could be a rectangle, could be a, trying to find a 4-sided shape in my head. But the idea is that a rhombus, sorry. It could be a rhombus, could be a rectangle, could be a square. And so in order to determine which one it is from that, then we're going to go ahead and actually mention that these are 90 degrees. So we need to know then that AD, for instance, is perpendicular to DC. because if it is, then there's 90 degrees here. Then we need to prove that DC and CB are perpendicular, meaning opposite reciprocal slopes. And then technically we only need to do one more, BC and BA, because if we have said that 3 of the angles are 90 degrees, then because of it as a four-sided shape, it has to add to 90. So in that case, we can go ahead and find the length of AD by using our distance formula. And so AD uses an x1 of -4 and a y1 of 1, and D uses an x2 of -2 and a y2 of -3. So if we plug it into this formula here, we're going to get the square root of x2, which is -2, minus -4. So -2 plus 4, since it's minus negative, squared. And then that is going to be added to our y's subtracted, so -3 minus 1. And then that quantity squared. All right, so solving this, that means that we're going to have the square root of -2 plus 4 is 2. 2 squared is 4. And 4 plus -4 squared is going to be 16. Again, -4, the quantity squared, means -4 times -4, so it is positive 16. So that means that our distance between A to D is the square root of 20, and so hopefully that's the same as B to C. So from B to C, we're going to use these two values here. So our x values subtracted is going to be 4 minus 2. And that's going to be added to our y's subtracted. BC, right? Yep. So 0 minus 4. And so that ends up being 4 minus 2 squared, which is 4. And 0 minus 4 squared, which is 16. And so again, we have square root of 20. So we now know that AD equals BC because both of them equal the square root of 20. And so we now have that those two sides are the same length. So we can now say that AB is the same length as AD, is the same length as BC. All right, if they all happen to be square root of 20, then it's going to be a square, but clearly that visual isn't here. So then we need to find the length of AB. And so the length of the distance from A to B is going to be our x's subtracted, so 2 minus -4, so 2 plus 4. And then that's going to be added to AB, 4 minus 1. And so we have 6 squared, which is 36, and that's going to be added to 3 squared, which is 9. And so we have the square root of 45. So as you can see, BC and AB are not the same, and so we can say that this length that we just found has 2 tick marks instead of the 1 tick mark to match. And then we're trying to find the length of DC, and so that's going to be the square root of our x's subtracted, so -2 minus 4 squared, and then our y's subtracted, so -3 minus 0. Squared here. And so that becomes -6 squared, which is -6 times -6, or 36. And then -3 squared, which is -3 times -3, so another 9. And so now we can see that these both equal the square root of 45. And so in that case, we have something that is more like a rectangle than a square or a, what am I looking for? A rhombus. So then the only other thing, other than noting that the opposite sides are the same length, would be to double check that everything happens to meet at 90 degrees. So again, we want to get our slopes so that they're opposite reciprocals. So we're going to find the slope of AD. And to get from A to D, you go with a rise of 1, 2, 3, 4. 1, 2, 3, 4, yep. And then a run of 2. So down 4, run of 2 is going to give us -2 as the slope of AD. Then we want the slope of DC, so we can say that they are perpendicular. So from D to C, you're going to go up 3 and over 6. So that's a rise of 3 and a run of 6, which means that we have a 1/2 as the slope. And since these are opposite reciprocals, that means that they are perpendicular. So those two are perpendicular, which means I can say that ADDC has 90 degrees right here. All right, continuing on, DC and CB. I have the slope of DC, but now I need the slope of CB. So from C to B, you're going to go down 4 and over 2. So again, down 4 over 2 means that that's going to be -2, which makes this opposite reciprocal as well, which means that those are perpendicular and that this is a 90-degree angle. And then the last one, to double check, we need the slope of BA. And from B to A, or actually A to B, you're going to rise 1, 2, 3, and run 6. So up 3 over 6 means a 1/2. And again, those are perpendicular. So we're going to put another 90 degree there. So all in all, based on all of these, we can deduce that this is also 90 degrees. And so we have a rectangle. Again, you're going to say something like, well, I could have done that without all of those pieces. But you have to do each of these pieces so that you can prove that it happens to be a rectangle. So opposite sides are the same length, super. They're also different opposite or different consecutive side lengths. So it's rectangle versus a square. And then, of course, all of the sides meet at 90 degrees. All right. The second example that we're going to do here has another polygon, in this case, and again, a 4-sided shape. On your notes, on your homework assignments, there will be some triangles as well, so that's fun to look forward to. So the first thing we can do is graph all these. So 1, 4 is our first point at W. 4, 2 is X. 2, -3 is Y. And -4, 0 is Z. All right, so taking a look at what we have here, definitely not a square. Kind of looks more like a trapezoid, and so remember that there are quite a few ideas of a trapezoid, but the most basic is that this side is parallel to this side. So we're going to go ahead and find out if WX is parallel to ZY, because we're hoping that it is WX parallel to ZY. And then double checking that XY and ZW don't have any relationship. So ZW. What's the other one? XY. All right. So, because of course, if we did this proof in the last example, we would have concluded it was a trapezoid, but clearly it was not a trapezoid, but it did make that opposite set parallel. So we just need to double check that the other piece has no relationship at all, and therefore we can say it's a trapezoid. So one set of opposite parallel sides is our definition we're working with. Once we determine that it's a trapezoid, we can go ahead and find each of the pieces to find its area. So notice that we are trying to not just classify it, but find its area. All right. And so we are going to first find the slopes of WX. And the slope of WX is your rise over your run, so down 2 over 3. And then we also need the slope of zy. And zy has down 3. 1, 2, 3, yep, over 4 plus 2, 6. So down 3 over 6. Okay, and so that's going to simplify to 1/2, and so those are not parallel. Looks like they're parallel. 2, 3. Ooh, yeah, not quite parallel, huh? All right, let's double check that I plotted them correctly. 4, 2, 2, -3, -4, 0. Okay. And so what other option could we have here? It could be a kite, but clearly that one is not the same length as that one. Those are not parallel, and so it looks like it's just a regular random shape. All right. So on that note, we do not have any classification, so we're not going to use this. So we cannot, it's no known shape, so it's just a quadrilateral. And so when we think about getting the area of this, we're going to have to just break it up into little triangles. So let's do that. So if we break this up into triangles, one of them is here with a height of 2 and a base of 3. Another triangle here has a height here of 1, 2, 3, 4, 5 and a base of 2. Another triangle that exists in here is going to be this guy. Another triangle is this one, and then sadly we have this little area in between. All right, so that's gross but doable. All right, so we'll go ahead and number them so that we can kind of reference what I'm talking about as we're going through. So triangle number 1, triangle number 2, number 3, number 4, and then this 5th shape in the middle there. All right, so triangle number 1, to find the area, we're going to do a 1/2 base times height. And triangle number 1 has a base of 1, 2, 3, 4, and a height of 1, 2, 3, 4, 5. I just was bad at drawing that. So a 1/2, 4 times 5 means that we're going to get 10 for the area of this first one. All right, then triangle number 2 is also a 1/2 base times height, but of course this one has number 2, a height of 2 and a base of 3. And so that means its area is 3. Triangle number 3 has an area of a height of 1, 2, 3, 4, 5 and a base of 2. So a 1/2 times 5 times 2 leaves you with 5 for the area of triangle number 3. Triangle number 4 has an area of a 1/2 base of, let's imagine it this way, 1, 2, 3, and a height of 1, 2, 3, 4, 5, 6. So times 3 times 6 means that we're going to have an area of 9. So we have 10 plus 3 plus 5 plus 9 plus that rectangle, which is length times width. And the length is 1 and the width is 2, so 2 times 1, so 2. So all of these circled areas added up, 10 and 3 and 5 and 9 and 2. Because this is not any shape that we can classify, it leaves us with, what number? 21 plus 8, so 29. So that means that we have 29 units squared, because we don't actually have a unit, so we just use the word unit. All right, now noticing this piece, this previous example we didn't quite answer because it did say find the perimeter and the area. So we are going to want to do that. So one more piece of example 2 is to find the perimeter. And since we did already find the length of all of these sides, that means that we're going to have a square root of 20, but two of them for AD and BC, so for these two sides. And then we're going to add that to 2 square roots of 45 for the perimeter. And just because that's kind of hard to look at, we'll just go ahead and get a decimal. So 2 times the square root of 20 plus 2 times the square root of 45. And so typing that into your calculator, you've got 2 square roots of 20, 2 square roots of 45. And so our perimeter ends up being 22.36. Doesn't necessarily say what to round to, so there we go. And then it's a perimeter, so just units and not units squared. The other piece that they want, other than classifying, is your area. And so in order to find the area, we can do our length times our width. So length times width is going to be a length of square root of 20 and a width of square root of 45. And so multiplying the square root of 20 times the square root of 45, which you could have given as their decimals, ends up being 30. And we are doing units squared since it's area. And so that actually answers the question. All right. So first example gave you a rectangle. So then we used the perimeter formula of 2 lengths plus 2 widths to get our perimeter. And then the area, we used the formula of length times width. All right, and then our next example, we couldn't identify what it was, so then we just broke it up into as many shapes as we needed to in order to find out that it had an area of 29 units. All right,